Yeah.
Okay. Today is the last lecture slot we have in the usability engineering unit, and it is about pervasive usability and ubiquitous computing. I don't know whether you're familiar with these terms, whether you heard it before, but what I will do is introduce you these concepts, what it means, and give you a few examples, and then we could discuss as well. As I mentioned, I have two of my PhD students presenting today. One will be talking about power chairs, wheelchairs for disabled users, how he used a smartphone on a wheelchair to control the interaction between the wheelchair and his car. So that's the PhD research he's looking into. And I have another student, and he will present you his PhD research to do with addiction, digital addiction, how people are addicted to social networking sites and so on. So what are the addictive features on social networking sites? And he's planning to do some sort of diary studies, ethnographic studies with users. Hold on, 1 second. So this is Paul. Paul started his PhD research around 6 months ago. So after I present my slides, which will take around 20 minutes, Paul will talk about his research. And his research is an example of pervasive computing. Yeah? Okay? So what I would like to do, as I said, talk about pervasive computing, introduce you the concept of ubiquitous computing, and what are the challenges in terms of usability with these two areas. And then assignment support. If you have any questions to do with the assignment, I could provide you some help, so we could use this as a Q&A session. You have seen this image before. This image was on the first lecture slot I had. It's to do with the transitioning from the mainframes into ubiquitous areas. So in 1960s we had mainframe computers. In 1980s we had PCs. In 2000 we moved into the mobile area, mobile computing, and 2020 and onwards is going to be the ubiquitous area. So wireless interaction and computers will be everywhere throughout our life and different environments and so on. An example of ubiquitous computing is smart meters which you have in your houses. Nowadays, if you're using electricity consumption and so on, you could get charts graphs showing you what day of the time you use it and so on. So smart meters is just an example of that. In terms of pervasive usability, it is considered as a design principle or an integrated approach. So it's to do with, if you are to implement a system, a pervasive system, in terms of the design process, how do you get the usability involved throughout the design and development of the artifact of the system prototype which you're developing. So it's an integrated approach. So what one could do is one could apply usability methods which you learned in this unit throughout each phase, each stage of the product design life cycle. So one example we looked at, which I mentioned, was this European project I worked on, and that was building a head-mounted display for firefighters to locate casualties trapped in a building. And the fireman's helmet is equipped with a HMD, head-mounted display, a camera, and it has a voice system, voice activation system. So the field operators could contact the person in the fire control to get some floor plans from them, some images and so on. This is an example of pervasive computing as well. And the way we developed this, as I said, you could use usability engineering methods throughout the design and development process. So all the way from concept to disposal of products which you're developing. So this was a concept demonstration. We've done some ethnographic studies, field work, interviews with the firefighters, and once we implemented the system, we've done some testing on it. So cognitive walkthroughs, user surveys with the user population, with the firefighters and so on. Another example which you looked at, which could be considered as pervasive computing, is the digital pens. So you looked into applications of use of digital pens for people with dementia, and then you develop some kind of solutions in terms of how it could be used. So this is another example of pervasive computing. In terms of the different phases of the pervasive usability process, it is quite similar to the user-centered design process which you looked at. So in the requirements analysis bit, you could perform field studies, interviews with your user group, focus group, even task analysis based on those to derive a requirement specification, categorize your requirements, and based on your requirements, then you could develop a conceptual model. And you could implement mock-ups. You could use usability inspection methods, cognitive walkthrough methods to evaluate your conceptual design before you prototype. And once you prototype, you could have mock-ups. You could again use usability inspection methods such as Nielsen's heuristic evaluation, cognitive walkthroughs to test it, and the implementation and deployment part, again, user testing, subjective ratings. You could use rating scales, questionnaires, interviews, focus groups, usability inspection methods. And when you're deploying it, you could have field testing. You could have tests in the field with the actual users to evaluate the system which you're developing. So this is an example of a pervasive usability chart. So in terms of pervasive usability, these are the areas, these are the, you could compare this to Nielsen's heuristics in a way. So you could map it onto those as well. Accessibility, compatibility, consistency, credibility, all the way to learnability and content. So in terms of the pervasive, ubiquitous system which you're building, how quickly is it for a user to learn it? You know, there's the smart meters at homes. How often do you engage with it? How quickly can you learn it? Is any training required? In terms of ubiquitous computing, this is also called pervasive computing. So there are two groups of people researching this domain. Some call it pervasive computing, some call it ubiquitous computing, but they emphasize the same thing. So you could use both. So this is more to do with computing is everywhere in our lives. So it is embedded into the processes, the chips, and it is connected with objects, with devices that we're using. So we're using smartphones, and we're using different gadgets, different devices in our day-to-day, to support our day-to-day activities. And what makes ubiquitous computing quite important is the mobile computing bit, so the connectivity, the Wi-Fi side of it. And we have the intelligent environment. So once you have the mobile computing and the intelligent environment, then that could be considered as a ubiquitous environment, ubiquitous computing environment. According to Professor Mark Weiser, so he did mention this, he said, in the 21st century, the technology revolution will move into everyday, the small and invisible. So we'll have, in military, for example, they have smart clothes. So they have equipment, military equipment, which is embedded into the clothes, and you wouldn't realize it is there. But the various sensors, various chips, physiological measurement tools to measure how soldiers are reacting to different environments and so on. So those are examples in the military domain. So Mark Weiss also mentioned the most profound technologies are those that disappear. So so it's in the fabrics. It could be built into the clothes, and they are indistinguishable. So you wouldn't be able to recognize them. So those are good examples of ubiquitous computing. What makes ubiquitous computing kind of easy to implement nowadays is we have small chips, we have a mobile computing which is evolving, we have external power supplies. When I worked on the head-mounted display example, that was back in 2006, we had to use a laptop in a rucksack. So each field operator had to carry a laptop with them, and that laptop was connected to the head-mounted display. But nowadays you have mobile for smartphones